Thanks for having me, everybody. As he said, Daniel Steelman, TTS. Most recently, Regional Manager of the Middle East and North Africa. Also taking over part of the business development on the drilling side, specifically our casing XRV, which will be presented on today. With the advent of friction reduction tools in a coil tubing world, longer laterals and the need to break friction to get pipe down, and then of course the drilling world taking over with friction reduction tools. We developed our own. We developed this in the vision of our coil tubing tool, so it's mirrored off of that. This tool specifically, the target at first was friction reduction. Longer laterals needed friction reduction, so we put this into a casing string to help drive casing to bottom, break the friction while you're driving casing. It goes directly into the shoe track. What we started to see after periods of measuring criteria and seeing some results, we went into the dynamic cementation principle. And that principle is just pulsating fluid and creating oscillating fluid through that tool without having to reciprocate or rotate pipe. That takes your cement, gives you a better cement bond log. The theory behind that is it's breaking the surface tension of mud at the casing. We're replacing that with cement, displacing more mud. And please, throughout this, I want you guys to interact. If you have questions, please ask. We'll answer anything you need to answer, or you need asked. Yes, sir.
Go back to that thing.
Yes, sir.
So the vibration is made in that machine right there.
That's correct.
Way out at the end of the pipe somewhere.
That's correct. In the shoe track, directly above the float shoe. Yes, sir.
All right, go ahead.
Yes, sir. You can set this up multiple ways. Like I said, it goes typically above the float shoe. In our 5.5 and 4.5, this is not a drillable component currently. We do have an option for that, but it's not necessary in most shoe tracks because you're not going to access below that anyway. We do have drillable options when you're running anything above in the intermediate strings or in your conductor casings. So we have this in every size available, every connection available, in any material. You can run casing joints in there for whatever reason, but as long as this is below your pressure activated components and any kind of landing subs, then you can put this in the shoe track directly. I'm sure everybody understands friction reduction tools by now. We have a little bit of a different approach to this. Most of your friction reduction tools incorporate a stator or a rotor with an OVA, SVA, some kind of pulsation device inside there using rubber components and rotation. We have no moving parts. This is completely a metal piece basically, and we have an insert that goes into a sub. We designed that insert based on your flow rate, your mud weights, and any type of chemicals that you're pumping down hole. We have a program that we put this into, plug in all of your information that you provide, and then it spits out what we want to set this tool up for. We design this tool per job. As it flows through, there's a little video, excuse me. I guess the video is not going to work. This is just going to show you this is an actuating valve. What we're going to do is we're going to accelerate and decelerate fluid in a valve. And as that is released, that's going to create you a pressure pulse or a pressure drop in the tool. This should play a video right here. So in our valve, excuse me, maybe. I apologize, that didn't download.
No, scan off where it's at.
I'll walk you through it. So in this valve, the fluid will come in. As this fluid comes in, it's going to hit this vortex, and inside that vortex, it's going to accelerate. As it accelerates through this vortex, it creates back pressure on the top side of the tool. When it releases and decelerates, it's going to create a pulse. That's going to happen about 13 times a second. We're running about 13 hertz on like a standard setup. We can increase or decrease that based on your parameters of your job. As this comes through, creates that forward movement, oscillates the pipe. It's an axial vibratory force, and it releases and gets your pipe moving and creates that friction reduction. And again, no moving parts inside that. Really hope this video works. There we go. This is a test we've performed. We're using the same type of pipe. This is just mud on a metal mesh screen just for a visual effect. This is for during rotating pipe. You're going to try to displace mud and you're trying to move mud. We're going to introduce vibratory effect on the right side, and it's going to show you the increase in mud removal from that metal surface. Now we're breaking the tension of that mud. We're going to move that mud, get that pushed up hole with the thicker and a heavier weighted cement, give you more mud removal, and then put cement where that mud was. We all want better production. We all want to drill better wells to get better production. Our target is to help you get to that point. This is not a replacement for anything that you're doing today. You're going to design your well the way that you want to design your well. You're going to pick your rheologies of your muds, how you're going to run your cement, and all the cement that you're going to put down hole. All the parameters are yours. We're going to give you a complementary tool to go in there to help you increase that cement bond. We believe that with a better cement bond, you're going to get a better frac. You're going to deliver sand where you need it to go. That sand's going to stay in those perforations and in those zones and in those clusters that you want the sand to be. We're going to try to give you better zonal isolation so you can actually see a zone, produce a zone, and get that zone to produce the way you want it to produce. We believe with that better cement job, you can get that better production through better frac. We've run these extensively in the US. It's really picked up in the last 2 years, I'd say. We've partnered up with a couple different operators, and we're running this on most of their wells, if not all of their wells. We've been shared CBL data, and we targeted a specific customer on a specific well pad. And when we look at these CBLs, these are 3 wells that are on the exact same pad, cemented by the same company, same wire line ran the CBL bond logs. Everything was drilled exactly the same. They're within a couple hundred feet of TVD and MD. So these are the closest offset wells that we could possibly get. And we ran this test specifically. The one on the left is our control well. That was run with centralization only. This is 6 3/4 hole with 5.5 casing. What you'll pay attention to is when you look at the CBL, you're going to start seeing the definition of a channel in that CBL. Here's your amplitude on this side. It's measured out in comparison to the others. The center technology was a chemical component. That chemical component is pumped down. It's supposed to mix with drilling mud, have a chemical reaction, create a high viscous or a high density fluid in there, simulating cement. And the casing XRV is here on the right. I'll play a video for you on this as well, and you'll be able to see from surface to toe, to see the CBL right next to each other with the control well and the XRV. Each one of these has their own identifying marks. Again, this one has a channel, an identified channel. On that CBL, it typically runs from about heel to toe. This here is an acceptable cement job by industry. This is what a lot of CBLs look like when we're just running cement in the hole, and everybody wants to get a little bit better. That well's going to get fracked. That well's going to produce. What we're trying to do is make this better for you as an operator or for the operator to get better cement, so maybe it produces a little bit longer, you touch a little bit more zones, and you have better cluster efficiency. When this produces a little bit better, refrac starts to change the mentality of refrac later on, potentially saving money. You're talking about anything from here to an ancillary effect of maybe your P&A at the end of the day is a little bit better because you have high density cement behind your casing. The chemical component that was pumped down hole, unconsolidated, it was showing a lot of channeling, a lot of fissures, and the drilling mud was not moving the way that they wanted it to move. On ours, we were running right about 5 millivolt average on the amplitude reading from heel to toe. We had a very, very good run on this. The customer ran more CBLs that we're sharing. We have USIT data from other customers as well supporting this. This is a waterfall video. What this is going to do, it's going to run the control well on the right and an XRV on the left. This is going to shoot through your free pipe passes and your vertical, get you down into the lateral, and you can watch the lateral right next to each other. These are all correlated depths, so we're running at the same exact depth. We're getting into the lateral now on the landing point, XRV on the left, control well on the right. You can watch the channel identified on the right with the control well. You can see good plugs, good zonal isolation on the left with the casing XRV. Our millivolt reading held pretty firm. Customer was extremely impressed by this, and then we were able to repeat that for that customer multiple times. I think we're up to, I believe, 66 tools ran with that one customer.
Are they also running a good centralizer program?
Good. So these wells are centralized. They are now moving to zero centralization as a test. They want to get rid of the centralizers and run this solely just with the XRV.
Where is this Middle East, you said? Or?
This is actually in southeast Mexico, or New Mexico. This is in Eddy County.
So looking at the tickers, it looks like he was passing 15,000 feet. So this is going to be a 7,500 foot, 10,000 foot lateral? 10,000.
Or 7,500 foot, excuse me. Yeah, 17. Yes, yes. We're currently running with them in 10,000 and 11,000 foot laterals.
Is there a point of like appreciation where like you see lesser cement like more towards the heel? Like how far back does the tool
We can get it at surface on a lot of jobs, and it really depends on your dogleg severity, what your hole looks like, any kind of deviations in the hole. So we can see the vibratory effect at the surface, especially in your hoses. You're still going to see that fluid pulsation. So when you're landed, and you're landed in your toe, that pipe may not be moving like, you're going to feel that vibration, but you're not going to be moving pipe at that point being at TD. But you are going to see that, and you're going to see that pulsations where it's still going through the float shoe with that pulsation within the fluid. We've ran some other collective data, and we started collecting data on one operator. This is all one operator in one area, holes drilled over a period of time. We whittled this down to the best offset wells that we could find. We wanted to measure production on wells using the XRV versus wells not using the XRV for that one customer, and then go in and present it to that customer. On the collective here, we were seeing a significant increase on production over those wells and the cumulative oil collected from those wells using the XRV. We did this in 4 different areas for that one operator. We did 2 different sections of the Permian, 2 different depths, one being the Delaware. I believe the other one was Midland Basin. So we were also moving from, and then the next 2 are in Oklahoma. And we did the same thing for them, and the data proved through there with all these offset wells, and then had them check the offset wells as well and come back to us with a report. So, and there's this.
Ruptured disc or anything in the shoe joint, or is that affected?
Well, they're running a float sub, so they're going to float casing typically as far as they can possibly go. When they hit that lockup point, instead of getting a rotation or trying to oscillate pipe, they feel like they burst that disc, and then they start running our tool, and they just start pumping on it. When it starts pumping, it starts moving.
So I'm talking about when you start the completion for your shoe joint, somewhere you might have a ruptured disc.
Like a TIV or something that for zone contact? Yes. Yeah, they're running this, they don't change anything in their string for us. So we could run with multiple different systems. We can run this with sleeve systems, with toe initiator valves. We don't currently have an option to run in wet shoe application. That's the only thing right now, but we are working on that. We're developing a tool for a wet shoe application. Basically going back to it, no moving parts, no elastomers, there's no temperature limitation on this tool. We can design this specifically for your job. We literally send out a casing questionnaire to the customer. They tell us the parameters, we take those parameters, we put it into our system, we run the report, and it tells us how to set up the tool. We don't have a flow restriction. If this tool wears out, nothing plugs off, nothing breaks, nothing bridges out inside the tool compared to a competitive tool. Our targets are increased mud removal, dynamic cementation. We do have this in the drilling environment as well to help drill, just like the NOV agitator or impulse tool, or we have a complementary tool as well. Based on industry standards, this is a low-cost option for a better cement job. And when you're going to customers, that's really what it is about. It's the bottom line. What can I give you when you do this for us, right? We do engineer every single job. We'll take every piece of your information, we'll work right alongside with you and work through every kind of issue or problems that we would potentially come into and design the tool for you. And then I'll open it up for more questions, please, if you have any. Sir?
Now, you said you put it right behind your toe?
Right above the float shoe, typically. Yes, sir. Yes, sir.
Okay. What is typically cost like for 5.5, 20?
Right now, 5.5, 20 pound, 15,000. Yes. So it's complementary to a float shoe or something else, or fits right in there.
4.5, 1350.
We can run it on anything. We design it by the API spec on the connection. So whatever your OD is, we're going to put the API connection on there, and we'll build it to that OD just to fit inside your shoe track. We've run this on tapered string. We've run this on long string. Pretty much any option you have. Largest we've run in here in the U.S., I believe, is 9 5/8, and we do have 13 3/8 open, and we also have, I think they were designing another one for 20-inch. We had a customer ask for a 20-inch. But we will run down to 4.5 right now. We can work other options when we're working on something right now for recompletions where they're driving liners, and we're trying to get a liner tool to help put help drive a liner to bottom. Sir.
Have you calculated how much fluid's moving back and forth while this thing's working, or is it?
It's not truly moving back and forth. It's just a deceleration inside that vortex, and to measure that in 13 times per second would be probably, I would need a bigger nerd than me to figure that one out.
Even 1 time per second, I can calculate.
Yeah.
But it's just very small volume.
Very small volume, yes sir, yes sir. It's the cumulative effect of that deceleration that's building that pressure drop inside that tool. And a lot of people are pressure limited, or they have only enough room in their standpipe to run, and we'll design the tool to fit within those pressure requirements for you.
What kind of pressure drop does it make?
We like to target right about 600 psi. 600 psi is pretty optimal for us. That's where we get the optimum amount of activity through the tool. But we do have nozzling inside that. Just like if you're going to nozzle out a bit and you're going to change your bit dynamics or your bit fluids, you can nozzle it differently and get a different reaction through that tool. Sir.
So semen rheology is going to be really important, I would assume. What you're talking about here, do you design it based on the tail semen slurry then? Because that's going to be what's going to last.
Right, you're going to train it, yeah.
How do you guys design that based on whatever rheology they're going through it, with maybe having a potential lead and then a tail?
Right.
Or something like that.
Yeah. That's when we work with you. It's kind of like what your target is. A lot of customers come to us and they'll say they have a problem getting pipe to bottom. If that's the case, and they're worried about cement as well, the cement becomes the ancillary effect. That's the added bonus at the end. We designed the tool to give you the best pressure drop when you're driving that casing, so you can land the casing where you want it to land. It's dynamic cementation is your target. That's when we sit right next to you and say, what do we want to do? We take all of your viscosities into account, all the rheologies of that mud, all your lead in, tail, all that. Put that together, design it out with you. This will work differently if you overdrive it or underdrive it, right? You're still going to get that fluid pulsation through that tool, even if you underdrive it. If you're targeting 600 psi and say your lead in is only going to give you 400 psi, you're still getting that vibratory effect. It's just not the impact that you're looking for. Right. If you want to get into that tail end, you say, hey man, I want to bump this thing up. I want to get this thing moving. We can design that for 600 or 700 psi at that point, give you a better, effect at that tail end cement. So it's kind of working with you and seeing the customer and listening to the customer on what their needs are, and then designing the tool out for exactly what they want.
And then the rate's going to be coming.
Rates pivotal, yes, absolutely.
Can you do this with nitrified cement?
Yes, you can. Yep. Low compressibility fluids is a challenge, of course, right? If you're running diesel through like a drilling tool, just low compressibility, right? So that's where you get into the dampened effect. Sir.
Have you run it in any vertical applications? And what I'm thinking of is like what exposure well where you're trying to get a
right.
lift and you're using a fairly light cement.
Yes, we have. We have used this in a vertical application, and the target there is centralization of that pipe inside that hole. So it's kind of like if you have a low side and you're laying down on the low side of the well, we're going to try to vibrate that pipe enough to get rid of that mud, and that cement starts to build in there. The longer you pump on it, of course, the more central it's going to become. So that's the target as well. Vertical is the same exact thing. If you go in there with helical buckling, one bonus to this is we're going to stretch the pipe. As that pipe is locked in, we're going to stretch that pipe out and try to pull that helical buckling out, because it's always going to want to move forward. As we're doing that, we straighten the pipe, we start to get it more central in the hole as well with that cement displacement. Anybody else?
What's the complementary drilling tool called?
The complementary, it's the drilling XRV. So we have casing XRV and drilling XRV. Soon we'll have it relaunched, because we're doing a couple different things in our drilling world right now. We're changing up a little bit for the internals and how this thing is driven. So we're actually going to relaunch that hopefully here in the next couple months with a new name. So.
The drilling one going to be, is the drilling XRV going to have drillable components in it?
It does not have drillable components, but there's multiple different things on the table right now for wireline retrieval for the inserts, so you can actually get through that if you have a problem and have to access below. So we have multiple different things, and when I said we need a bigger nerd, we have a couple of them that work for our company that are pretty good at their job. So I know. I'll add to that. Yeah, Cliff's over there trying to stay quiet, right? Sir.
Do you have a generation that had moving parts in the beginning?
We had the Achiever in the coil tubing world, but that was many moons ago. But no moving parts on our drilling tools or casing from inception.
All right, with that, we're going to wrap it up.
All right.
Thank you, Daniel.
Thank you.
Appreciate it.
Appreciate it. Thank you.